In this video, we're going to begin our look at linked lists. A linked list is a data structure. It's a sequential list of objects, but this time arrays aren't involved. In a linked list, each item in the list is aware of another item in the list because each item in the list contains a link to the next item in the list. Now, this is different from arrays and lists that are backed by arrays. With an array, each item in the list is completely unaware of either other items in the array. But items in a linked list know which item comes after them, and that means that we have to store some extra information with each item. When we have an array of integers, we just have to store the integer value in each position. But when it comes to a linked list, we have to store the integer value, and we have to store a reference to the next integer in the list. So when we get to the implementation, I'm going to use the employee class we used when we looked at array lists. And so on the screen here, I have a linked list, and this would be Jane, John, Mary, and Mike. And as we can see, this blue block would be the employee object, and then there'll be a field that contains a reference to the next item in the list. Each of these items is referred to as a node, and the first item in the list is the head of the list. And the last item in the list always points to null because nothing comes after it. And so what we'll have is a node class that contains a field for whatever data you're holding in the node. In our case, we'll have an employee field, and then we'll have a next field. And that next field will be of type node because each node points to the node that comes after it. Now I'm going to insert a spoiler here. In Java, you wouldn't implement a linked list yourself. There's a linked list class, but to help us understand what a linked list is and what its advantages are, we will code a simple implementation. So as I said, when it comes to a linked list, there will be a head field, and the head will point to the first item in the list. So if you have a reference to the head, you can traverse the entire list. You would start at the head, and then you'd go to head.next, and then you'd go to that next field, that next one, until you hit null. So for a linked list, the only thing you have to store is a reference to the head, or the first node in the list. And from that, you can get to every item in the list. So let's talk about what we'd have to do to insert an item into this list. So let's say we wanted to insert Bill. Well, the first thing we're going to have to do is create a new node for Bill. So we'd have a box somewhere that has Bill in it. When it comes to linked lists, you always insert a new element at the front of the list, and you can understand why. We only ever store a reference to the first element, and so if we wanted to insert an item anywhere other than the front, then we'd have to traverse the list to get there. And one of the advantages of using a linked list is that if you insert items at the front of the list, you can do it in constant time complexity because the steps you have to do don't depend on the number of items in the list. You're always going to do the same number of steps. So we create a new node for Bill, and we're going to want to put Bill here or up here in front. Bill is going to want to point to Jane. So after we've created the new node, we'll assign the next field Jane, and then we're going to assign head to Bill because Bill will be the new head of the list. And so that's all we have to do to insert a node. We create the actual node instance. We point the next field at the current head of the list because the new node is going to become the new head. And then we point the head field at the new node. And that's going to always be constant time complexity because it doesn't matter. You could have 3 items in the list or 1,000,000 items in the list. And you're just going to do the same number of steps as long as you're inserting at the front of the list. And so after the insertion, this is what the list would look like. Bill's next field points to Jane, and the head field now points to Bill because he's at the front of the list. So how about deleting? Now, what if we wanted to pull Bill off? And once again, we'll want to delete from the front of the list. Otherwise, we're going to have to traverse the list looking for the node we want to delete. Now, in the implementation, I'll show you when we do a deletion, we return the node that we deleted. So we're first going to assign Bill to a temporary variable called removed node. And then what do we want to do? Well, all we're going to do is move the head to Jane because that effectively removes Bill from the list. because for a linked list, the only sort of information that we're holding is this head field. And so if we break this link to Bill and we change head so it's pointing to Jane, Bill has effectively been removed from the list. There's no way we can get from head to Bill. And then at that point, we would return the remove node, which we previously stored Bill into that field. And that's all we have to do to delete a node from the front of the list. Once again, this will be constant time complexity because it doesn't matter how many items are in the list. You're going to do the same number of steps. So after we've deleted Bill, this is the situation we have. Bill will be hanging off here. He'll still be pointing to Jane, but there's no way for us to reach him from the head of the list. And if we wanted to do cleanup, we could set Bill's next field to null if we wanted to. And so that's it for sort of the theory for linked lists. They're not that complicated. They're the second data structure we've looked at, the first one being arrays, and they differ from arrays in that as long as you're inserting and deleting from the front of the list, the insertions and deletions are done in constant time, and that's because there's no shifting involved. And this type of list is called a singly linked list because we have one link between every node. In a little while, we're going to look at a list that's called a doubly linked list. But we're starting out with a singly linked list. And when you're working with a singly linked list, you want to insert and delete items at the front of the list because you only have a reference to the head of the list. And so if you want to insert and delete items anywhere else, you have to start at head and you've got to traverse the entire list to find what you're looking for. All right, so now that we know a little bit about singly linked lists, let's implement one. I'll see you in the next video.